Welcome learners for the lecture 7 of a differential geometry. Okay, today we discussing about the curve of the surface. Definition first will be given to the lecture first. After that definition second will be given to the form. Okay, let us go start it. Definition second. For the curve on the surface, let u equals to cx and v equals to c2 when the constant c1 and c2 vary. The whole surface is covered with the net of parametric curve, two of which pass through the every points u and v are called as a curvilinear coordinate of the p. The parametric curve are called as a coordinate curve. This coordinate curve considering two forms, that is u and v. First of all, clearly said that what is u and v will be considering to the form for the domain of the curvilinear function. Okay. Next definition will consider this form. Two parametric curve means not given to the one, it will be considered as a two parametric curve through the point P are said to be orthogonal if R1 into R2 equals to 0 at said to be orthogonal if R1 into R2 equals to 0 at a point P if this condition is satisfied for the every point U and V of the domain. Okay, then the two system of parametric curves are orthogonal. Means two parametric curve are the point P is said to be orthogonal if R1 into R2 equals to 0 at point P. If this condition is satisfied to the every point of a U and V will be the domain, then the two system of the parametric curve are the orthogonal. Okay, this will be the definition. After that, next point will be given, that is the tangent plane and the surface normal. Let R equals to RUT and VT will be the general curve lying on the surface passing through the point UT and VT. Then the tangent to the curve at any point P is on the surface of the curve will be given to the form. Okay, what is two form will be generated in this equation? Then the tangent curve of the P on the surface will be given as a tangent plane. Then this equation is generated by the dr upon dt equals to del r upon del u. Dr upon dt equals to del r upon del u into du upon dt plus del r upon del v. You know that equation will be considered to the form d will be simply given as a derivative form and delta will be given as a partial derivative form in the both of the equation. Then considering del r upon del u into r1 and del r upon del v equals to r, both of the r1 and r2 given to the condition. This is equation first will be given. Then definition first of the tangent plane will be given to the form. The surface line will be generated. Okay, tangent to any curve drawn on a surface is called as a tangent line to the surface. If any tangent will be drawn on the surface, then this tangent line is called as the tangent line of the surface. From equation 1 we see that the tangent vector dr upon dt is the linear combination of both r1 into r2. Since r1 into r2 is not equals to 0, r1 and r2 are the non-zero and independent value, then the tangent to the different curve through the point P on the surface line in the plane containing two independent vector r1 and r2 at a point P. This plane is generating to the r1 and r2 for the r1 into r2 is not equals to r1 into r2 is not equals to 0. This both of these conditions should to the tangent plane at the point P. Okay, this will be given. Let us go started as a first theorem for generating to the value. The equation of the tangent plane at a P on the surface with the position vector r equals to r, u and v for the domain is either r equals to r plus a r1 plus b r2 or capital R minus small r into r1 into r2 equals to generated 0 where a and b are the. Then let us go start a tangent plane will be considering to the equation form will be generated. Okay, let given to the form r equals to r uv be the position vector at a point P on the surface. The tangent plane at a P passes through the point R and contain to the vector R1 and R2. So if to given as a position vector R on the points of the tangent line at a P, then R minus small r, R1 and R2 are coplanar, not a collinear, both of these condition. Okay, hence we have given to the equation capital R minus small r equals to a r1 plus b r2 for given to the condition of this equation, where you know that a and b are the parameters will be shown to the arbitrary constant. R1 into R2 is a perpendicular to tangent plane at a P. Hence, R1 into R2 is the perpendicular to R minus small r lying to the tangent plane, to show that to the capital R minus small r into R1 into R2 equals to 0 is another form of the equation tangent plane form to the at point. This is the given to the condition, that is the both of this equation is the main point of this theorem, that is the R1 into R2 is a perpendicular form to that condition.